What is love? It's a question poets and philosophers have wrestled with for centuries, right? But what if I told you the most concrete answers aren't in a book of sonnets, but right inside your own head? It turns out neuroscience can actually give us a surprisingly clear look at what's going on. Yeah, that's the big one. We've always thought of it as this grand mystery. But from a scientific perspective, love is, well, it's a powerful biological program, one of the most powerful we can experience. See, it's not just some fuzzy, abstract emotion. It's a neurochemical cascade. Think of it like a chain reaction, a predictable, measurable flood of chemicals in your brain. And this cascade is responsible for everything: the obsession, the euphoria, the deep feelings of attachment, and yeah, even the very real pain when it's gone. And here's where it gets really wild. This isn't an exaggeration, it's straight up biology. That dizzying, all-consuming rush you feel when you're first falling for someone, it lights up the exact same reward pathways in your brain that a powerful addictive drug does. So in this explainer, we're gonna break down that whole journey. We'll look at it in 3 key stages. First, you've got the rush, that initial infatuation. Then comes the bond, the attachment phase. And finally, the pain, which covers both heartbreak and, importantly, how our brains heal. All right, let's dive into section 1, the addictive brain. We're talking about that intoxicating, can't eat, can't sleep feeling. You know the one. From a neuroscience perspective, this is your brain's reward system getting, well, completely hijacked. The star of this show is a tiny little spot deep in your brain called the ventral tegmental area, or the VTA. Now, this is your brain's core motivation center. It's the part that says, yes, I need that, for things like food and water. It's also the part that gets hooked on addictive drugs. And, you guessed it, brain scans show it just lights up like a firework when you're looking at a picture of the person you're falling for. So when we say this, we mean it. This is not a metaphor. Love is literally addictive. That VTA pumps out a flood of dopamine, which is what creates that intense focus, that euphoria, and that powerful drive to be with that person. It's the exact same brain response an addict has when they're seeking a fix. And just how powerful are we talking? Get this. Some studies show people in the early stages of love can spend up to 85% of their waking hours thinking about their partner. That's not just you being a romantic. That's your brain's chemistry basically commanding your attention. Okay, so you ever wonder why they say love is blind? There's a real neurological reason for that. While that reward system, the VTA, is going completely wild, another part of your brain, your prefrontal cortex, which is your judgment and rational thought center, it actually quiets down. Your brain literally turns down the volume on the part that would normally be screaming, hey, hold on, what about all these red flags? Okay, so on to section 2, the attachment bond. Because let's be real, that intense dopamine-fueled high, it can't last forever. Our brains just aren't built for it. So after a while, maybe 6 months, maybe a couple of years, a really important chemical shift starts to happen. We move from that passionate obsession into something deeper, a real lasting bond. So what's happening is a great chemical shift. The star of the show isn't dopamine anymore. That's the chemical of I want it. Instead, 2 other key players step onto the stage, oxytocin and vasopressin. And these are the hormones of bonding, of comfort, of deep commitment. And this is why these 2 stages of love feel so different. Because chemically, they are different. Infatuation is all dopamine. It's thrilling, it's euphoric, but it's also kind of unstable. Attachment, on the other hand, is driven by oxytocin. It's calm, it's secure, it's built to last. Now, this is so important. A lot of people really start to panic when that initial fiery passion cools off. They think, oh no, are we falling out of love? But what neuroscience tells us is no. It doesn't mean love is ending, it means it's maturing. You're not losing something, your brain is just shifting gears into a different, more sustainable state of love. But what happens when that bond breaks? That brings us to section 3, the science of heartbreak. And the science here confirms what anyone who's been through it knows deep down. The pain isn't just in your head. It is very, very real. Seriously, if you've ever felt that ache, science is here to tell you you are not being dramatic. When you say your heart is broken and it hurts, you are not speaking in metaphors. Your brain is generating a genuine, measurable pain signal. And here's the incredible reason why. Brain scans show that the emotional pain from a breakup lights up the exact same part of the brain that processes physical injury. It's a region called the insular cortex. That's why you can feel a literal ache in your chest. Your brain is using the same circuitry for that social pain as it would for, say, a broken arm. And then, to add insult to injury, there's this really cool twist. When you're going through a breakup, that reward center, the VTA, kicks back into high gear. It starts screaming for that dopamine hit that your ex used to provide, but it can't get it. And what does that create? An intense, painful craving that is neurologically identical to addiction withdrawal. But as awful as that all sounds, that is not the end of the story. And that brings us to our final section, how the brain actually heals. Because recovery from heartbreak isn't just about willpower or getting over it. It's a predictable, physical process of your brain rebalancing itself. And this is the science behind why the no-contact rule actually works. It's not about playing games, it's about brain chemistry. Every time you see or talk to an ex, it's like giving a tiny hit to an addict. It just reactivates that craving in the VTA and starts the withdrawal all over again. Going no contact is what finally gives that system a chance to quiet down, so your rational brain, that prefrontal cortex, can get back in the driver's seat. You know, this really reframes that old saying, time heals all wounds. It's not just a nice thing to say, it's a biological fact. Time heals is literally your brain physically rebalancing itself. Over time, that rational prefrontal cortex reasserts control over the emotional centers. It's a real physical process of your brain finding its equilibrium again. And this is maybe the most important thing to remember if you're going through this. Your brain isn't broken. You're not weak. What's happening is your brain is running a very, very old survival program. See, for our ancient ancestors, being kicked out of the tribe was a death sentence. So your brain evolved to treat social rejection as a life or death threat. And it still reacts that way, even though our world has changed. So let's bring it all home. What is love according to your brain? Well, it starts as a dopamine-fueled obsession. It matures into an oxytocin-driven attachment. If it's lost, it becomes a very real pain processed by your insular cortex. And finally, it's a healing process led by your prefrontal cortex that lets you get back out there and do it all over again. Which brings us to the final big question. Does knowing all of this, knowing it's just brain chemistry, make love feel any less meaningful? Or does understanding the incredible biological dance happening inside our own heads make it all the more fascinating? I'll let you decide.